This section is on inverse trig functions, and it kind of is a throwback to the inverses that we talked about in college algebra. Remember, it was a kind of a four-step process. We would change f of x to y, swap the x's and the y's, and then solve for the new y equation. Kind of the same thing going on here with the trig function. So functions f of x have inverses if they pass the horizontal line test, just like we saw in algebra. For example, we know that a parabola is not going to have an inverse function because it doesn't pass the horizontal line test. It hits more than one time if I draw a horizontal line through it. The graphs of sine and cosine, as they stand, will not pass the horizontal line test either, but to make them pass, we sort of truncate their domain. So we restrict the graph. So looking at the sine function, if I look at it from just negative pi over 2 to pi over 2, negative pi over 2, from 0 to negative pi over 2 would be, remember, quadrant 4, and 0 to pi over 2 is quadrant 1. So if I think about it on the unit circle, I'm looking at values here, and they're negative angles here, down here in quadrant 4, up here in quadrant 1. So if I restrict the domain, now it is a one-to-one function, and I can then find the inverse of it. So remember from algebra class, the domain and range are interchangeable because the x's and y's get flipped. So the domain of the regular trig function is now going to be the range of the inverse, and vice versa. So for here, the domain for the inverse function is going to be from negative 1 to 1, and the range, the output, is going to be some angle answer between negative pi over 2 and pi over 2. Similarly for cosine function, only now we restrict the domain between 0 and pi, as opposed to negative pi over 2 to pi over 2, because you see if I do it between negative pi over 2 and pi over 2, I'm not going to pass the horizontal line test. So I've shifted it from 0 to pi. So the domain then of the inverse function, and that's what this negative 1 here means. It doesn't mean raised to the negative 1 power or anything crazy like that. It just means the inverse. The domain for the inverse function is negative 1 to 1. In other words, the values that I can plug in for x here have to be between negative 1 and 1, and the output, my answer, is going to be an angle in radian measurement between 0 and pi. Inverse tangent function, kind of the same as the sine function. The only difference is the domain for the tangent, inverse tangent, is from negative infinity to positive infinity. And the range goes from negative pi over 2 to pi over 2. Once again, the angle answer that you're going to be given has to be between, or has to be in quadrant 4 and quadrant 1, and you're coming around in this direction, so it's going to be a negative angle from quadrant 1, or an angle from quadrant 1. So kind of the difference between, let's go, I guess, go to the next page. From unit 1, it was sine of an angle, we called that angle theta, gave me a ratio. That ratio was some fraction that we found on our unit circle, and for sine it was the y-coordinate. Cosine of an angle gave us the x-coordinate. All right, again, angle was the input, ratio was the output. For the inverse function, all right, now it's going to be sine inverse of the ratio, and our answer is going to be the angle. And that angle can't just be any angle. It's got to be the one that was specified on the previous page, an angle between negative pi over 2 and pi over 2. Cosine inverse of the ratio. So when you do inverses, the ratio, or that fraction, like 1/2 or radical 3 over 2, goes inside. and outside comes the angle, and that angle has to be between 0 and pi for the cosine inverse range. Tangent inverse, again, ratio inside and outside is an angle in radian measurement between negative pi over 2 and pi over 2, not including either of those endpoints. Because at those endpoints, that's where the tangent function is undefined. Remember, that's where we have our asymptotes. All right. So find the exact value of sine inverse of 1/2. So keep in mind, our answer has to be between pi over 2 coming in this direction and 0 to negative pi over 2 coming in this direction. Since it's a positive 1/2, we're looking to see what angle gives me the y value of 1/2, and that would be pi over 6. We can't pick, for example, well, I know over here at 5 pi over 6, I have a positive 1/2 as well, but the thing is, the inverse function can't be in quadrant 2. It's got to be either in quadrant 1 or quadrant 4. That's it. This number, this angle that you give me, has to be one between negative pi over 2 and pi over 2. You don't get to pick any other range. So for the next one, find the exact value of cosine inverse negative radical 3 over 2. So again, thinking about where the x value is negative radical 3 over 2, and again, it has to be between 0 and pi for my answer if we're talking cosine inverse. So for this one, cosine is negative over here, and the x value is negative radical 3 over 2 at, and this would be 5 pi over 6. Got to know your unit circle. Tangent, square root of 3. All right, well, we're looking at, our y over x has to be a ratio of square root of 3, and the y value is the sine value, the x value is the cosine. So I'm looking at where do I have square root 3 over 2, comma 1/2. Keep, change, flip will reduce to radical 3. So I'm looking on my unit circle between 0 pi over 2 and 0 negative pi over 2. It's going to be over here. And my x value is 1/2. And my y value is radical 3 over 2. So it's going to be up there at pi over 3. Okay. So where's this, and that's really what they're asking you, where does the sine value equal negative 1? That's what this whole thing means. Where does sine equal negative 1? What angle? So again, remember you're restricted between here to here. And sine would be negative down here, because this is the point 0 and negative 1. But that's not 3 pi over 2, because you're coming around in the wrong direction. You've got to come around clockwise. So this would be negative pi over 2. Right? 3 pi over 2 is out of bounds. Remember, this number, this answer has to be something between negative pi over 2 and pi over 2. Cosine inverse, where does the cosine function equal radical 2 over 2? And again, your choices are for cosine, quadrant 1 or quadrant 2. And you would be sitting right about there. So that's going to be pi over 4. Okay. Tangent inverse equal, where does the tangent function equal negative radical 3 over 3? So it's a little tricky, but again, it's kind of the same idea. We're looking for a ratio a radical 3 over 3 where we're y over x. And we don't have a whole lot of choice. If I do 1/2 radical 3 over 2, keeping in mind that I have to be either in quadrant 1 or in quadrant 4. Quadrant 4, the sine value is negative, cosine is positive. So a negative on the 1/2, positive on the radical 3 over 2. And if I do keep, change, flip, or cross out my 2's, this looks like negative 1 over radical 3. But if I rationalize, that's the same as negative radical 3 over 3. So the question becomes, where is your y value equal to negative 1/2 and your x value equal to radical 3 over 2? And that would be sitting right about there. And again, coming around clockwise, that would be negative. And it's the opposite of what's over here. Here it was pi over 6. So down here is going to be negative pi over 6. I think on the next 3, I'm going to have you try it. I'm going to hit the pause button and then I'll write in the answers. You compare your answers to mine and we'll come back in just a moment.